Hello friends, welcome to Electronic Circuit Hub. So today we are going to understand about the basics of EMC. So I have entitled this presentation to EMC Overview. So we'll understand what is EMC, why do we need EMC, what is the impact of EMC, and what all tests we need to do to get a certification, right? To get a product certification or EMC certification. Okay, so I will encourage you guys, please watch this video till end up, and I'm pretty sure that you will end up learning something. Okay, so let us start the video. You can see here, this is EMC, so-called EMC triangle, right? So under the EMC triangle, I have written and titled this presentation to EMC overview, right? So basically three terminology which will be used throughout this presentation is source, source or transmitter, victim, victim or receptor or receiver, and the third one is the coupling path. Okay, so basically the source, victim and coupling path forms a EMC triangle, right? So let us go ahead further. So basically I correlate EMC to a black magic. Okay, so if you know the basic definition for black magic, you can understand what is EMC. Okay, the question here is, now we are trying to understand what is EMC. So let us understand first the black magic. So you might already know in the black magic, right? So in the black magic, you can see something is happening for sure, but you don't understand how it is happening. It is similar case for EMC as well. Something happens for sure, but you don't understand how your product is being get impacted by the EMC, right? So just I'm trying to correlate black magic to EMC. Hope you understood now, right? Let us move ahead. So the first question arises here: why do we need EMC testing for any electrical and electronics appliances? Okay, why do we need? So if you don't get your product passed to the EMC, you will lead your problems with non-compliance of your product. What if your product is non-compliance? Your product may be blocked from the market, and maybe its practical impact can be either minor or major. Major can happens in the product. Okay, so if you say what is the impact of EMC in your product, so I will divide it into from minor impact to the major impact. So if you talk about the minor impact, it may be annoyance or delays in your telephone, cell phone, AM, FM, XM, TV interface, etc. If you say it's a bit more than minor, so you may lost your revenue, your minor property loss, which can cause the critical communication interface interruption or automatic monetary transaction. So this cause you the loss of revenue or minor property loss. Then there is a major impact due to EMCs, like your radar, landing system interruption, like your ordnance firing, improper development of airbags, which may cause a serious death or injury. So guys, this video I'm making for the education purpose only, right? Let us move ahead to the next slide. What is the problem, basic EMC problems you might need to know, right? So what happened in 2003, there is a Brazil rocket explosion. So due to that, killing of 21 people and injuring of 20 more people. And one more incident happened in 1967, the aircraft carrier explosion in the US, Vietnam, right? So why you need to pass your product with EMC? If you do your product uh, will not comply, EMC comply, you may see this type of injuries or this type of incident, right? So let us understand the EMC and how do you correlate EMC with your product development life cycle. Okay, product development life cycle. So you can see here two lines. One, this is something like you can see if the EMC not considered, then what will happen, and the second line is this one, this if EMC considered at start. Okay, if EMC do not considered at start, what will happen? If EMC considered at start of your design, what will happen? So you can see this is the design phase, this is pre-production phase, and this is production phase. So in the design phase, if you don't consider your EMC, what will happen? What will happen? You might have, you can see there is a cost here. Okay, so this is cost versus your EMC impact, right? If you don't consider EMC at the design phase, you might end up a lower cost, right? And if you consider EMC at design phase, you might end up at a higher cost. Let's talk about pre-production phase. If you don't consider EMC at a design phase, you may see at pre-production phase your EMC impact is much higher, that will cost you more, and this case your EMC impact is less and that will cost you less. And in the production stage, you can see if you have considered your EMC at design phase, there is a very less impact with the cost and with the product quality. And if you don't consider at design stage, you can see your at the production your product cost is higher, right? So this is basically cost versus your EMC constant. Okay, if you consider that design, what will happen? If you don't consider that design, at production phase, what will happen? And likewise. Let us move to next slide. What is bad practice and what is good practice for EMC? Like, so let us understand what is bad practice first. Yeah. So first you have to specify your EMC requirement, then you have to design your EMC requirement. This is pre-production phase and that is the launch phase. Okay, so if you don't consider specify your EMC at very early stage, what will happen? If you go at the launch stage or pre-production stage, you might need to iterate your design and you have to go back again to the design phase. That will waste your time. Okay, and you might also end up your product may not comply the EMC test. Okay, what is the good practice? Good practice is you have to specify your EMC requirement at the early stage of the design. Then you have to at the early stage, at the requirement stage, then you have to design for UMC. You have to design your product for EMC requirement and test it here and iterate it here if you have some findings, and then go for the pre-production and launch. You may say your product will get comply with the EMC, right. If you do something here at design stage, you will have confidence at confidence of some test, right. So this is basically, you have to follow the good practice. You have to follow your good practice. You do not need to follow this practice like this bad practice, right? So what is EMC definition as per IC 61000-1-1? So what it says is the ability of device or unit of equipment or system to function satisfactorily in its electromagnetic environment without introducing intolerable electromagnetic disturbance to anything in that environment. Okay, so this definition is basically given in the IC 61000-1-1 standard. You can follow this standard, you can find this definition, right? So if a system is said to be electromagnetic compatible if it does not cause any interface with the other system, it does not susceptible to emission from other system, and it also does not cause interface with itself. So this is basically given in the IEC standard. Let us move to next slide. So you can see here EMC stand for electromagnetic compatibility. It has two legs. EMC has two legs. One is EMI, other one is EMS. EMI stand for electromagnetic interface. EMS stand for electromagnetic susceptibility. So under the EMI, you can see you have radiated emission and conducted emission, right? So you have radiated emission and you have conducted emission. Under the radiated emission, you may have your magnetic field, electric field, conducted power disturbance. These all things comes under radiated emission. Under the conducted emission, it's in the form of voltage and current. Let us talk about EMS, electromagnetic susceptibility. So electromagnetic susceptibility is like in the form of magnetic field and electric field. Let us talk about conducted susceptibility, that is called CS, conducted susceptibility. I think it's written something wrong here. Instead of CE, there should be CS. Okay. So in the conducted immunity, you have like CS, surge, EFT, burst, it, ESD, etc. Okay. Let us move to other slide. What is the causes of EMC? This is very important topic. How EMC is being generated in your product. Let us understand this. Okay. So let us understand you have this lighting spark, lightning, which can impact your product. Here you can see you have radio and TV broadcast antenna which may impact your product. You have ship that is also impact your product. You have radar system that will impact your product. You have walkie-talkie that is impacting your product. You have mobile radio, or you have a car that may impact your product. You have some electric motor that may impact your product. Okay, in the form of conducted noise or in the form of radiated noise, right? So these are the basic cause of your EMC, right? So what is EMC environment? So I already told about there is emitter as source, you have your coupling path or conduction path, and then you have your victim or susceptible or receiver. Okay. So this let us understand more further in next slide. So what is electromagnetic environment basically? So all electronics device produces electromagnetic radiation but can be classified into these parts, like some electronic devices are intentional transmitter, intentional emitters like broadcast transmitter, mobile phone, wireless LAN, remote control transmitter. Okay, these are called intentional emitters. And there is some device which is called intentional receptor like TV receiver, mobile phone, wireless LAN. Okay, some devices are called unintentional transmitter or emitters like digital circuit, oscillator, switching circuit, audio ignition, lighting, ESD. Okay, and that cause the interference. Some devices are also called unintentional receptor, that is telephone lines, audio video system, analog circuits, digital circuits. Okay, some devices are all of above. They intentionally transmit and receive EM wave via antenna and unintentionally transmit and receive EM wave via its radiation or internal circuitry. So this is basically a electromagnetic environment, right? So basically there is two type of EMC in the product. If you talk about your product, it can have two type, like intersystem EMC. Intersystem EMC, you have to comply your product with regulation, and you have to get your certificate to pass this intersystem EMC. Okay, source and victim are in two different pieces of equipment, and a victim may be also source. So in the inter-system EMC, you can see your source and victim are two different equipment. Like your source could be your electric motors, your mobile radio, your radio and TV broadcast, and it can also be a victim. So that is called inter-system EMC. What is intra? The second one is intra-system EMC. In the intra-system EMC, you have to get stable operation, performance, and the quality. So your source and victim are in the same piece of equipment. Okay, so they are in-house, and your source and victim are in the same piece of equipment, and due to E field coupling and H field coupling, they can interface other circuitry. Okay, so what is basically to be measured in EMC? There is four parameters to be measured in EMC. That is like, you can see here, this is conducted emission, this is radiated susceptibility, conducted susceptibility, radiated emission. Okay, here you can also see conducted emission and conducted susceptibility. So basically, conducted emission, radiated emission, conducted susceptibility, and radiated susceptibility, basically there are four parameters which need to be measured to comply product EMC, to EMC comply, right? Let us move to next slide. What is EMC achievement? The product shall be designed in a such a way so that it can meet the regulatory requirement. If it meets the regulatory requirement, that means you have your EMC achievement. And what about conducted and radiated emission? Your product should remain within the specified limit. And what about CS and RS, conducted susceptibility and radiated susceptibility? Your product should remain immune up to a specified limit, right? So this, if you have these limits for C, RE, CS and RS, you can say you have your EMC achievement. What is, until now we have understood what is EMC, how many types of EMC we have, like EMI and EMS. Let us understand particular things. What is EMI? Electromagnetic interference. Okay, so what is EMI? Electromagnetic interference, the phenomena in which one component or subsystem interferes with the proper operation of another subsystem due to the propagation of electromagnetic energy. Or you can say, in other word, EMI is defined as any electromagnetic disturbance, whether intentional or not, that interrupts or obstructs or otherwise degrades or limits the effective performance of electronic or electric equipment. They are called EMI, electromagnetic interference. So you can see here, this is the basic block diagram of EMI, electromagnetic interference. Here you can see your source, right? And you can see this is the inductive coupling. This I took from the Wikipedia, right? So this is the inductive coupling, and then you have conductive coupling. Here you can see this is the capacitive coupling. From source to victim, you have different path to get it disturbed. Like you can follow, your EMC can follow the inductive path or conductive path or capacitive path. It can also follow the radiative path to disturb the other system. Okay, to disturb the other system. So this is basically called EMI. So in the image here, you can see you have your electronic circuit board, that is PCBA, printed circuit board assembly, and you can see your EMI can couple through the wire or power leads, which can impact other product, other system. And your EMI also can coupled using your radio electromagnetic wave. You can see this image, this stand for the electromagnetic wave. So it can be coupled through cable, or it can be coupled through air via electromagnetic wave, right? So So let us now understand, this is all about EMI, what you have learned, how your EMI impact the system. This is all about EMI. Okay, so this two, with this image and this image state for the EMI. Let us now understand EMS. What is electromagnetic susceptibility? EMS is defined as the inability of a device, piece of equipment or system to perform without degradation in presence of electromagnetic disturbance. Okay, so now now you have your PCB boards, PCB assembly here, and you can see your noise can coupled through the cable to an impact to this PCBA or your product, and it can also coupled through electromagnetic. Your noise can also coupled through your electromagnetic wave, and it can impact to your product. So that is called EMS. Okay, you can also see the example of electrostatic discharge. Okay, so your product should be immune enough to withstand the attack of EMS, right? So basically there is a three blocks in EMC. As I already explained, source, coupling path and receivers. So to reduce the interference at receiver, this is the receiver. So you have source, you have subcoupling media. We have already understood what is coupling media, how your noise is being coupled from your source to your receiver, that we have understood. So now to reduce the interference at the receiver, what you need to do, is suppress the source emission. Okay, suppress the source, you need to suppress the source emission. To suppress the source emission, you might need to modify your electronics, you might need to add your filtering circuit, you might need to add shielding in your product, right? To make coupling path as inefficient as possible. How will you make your coupling path inefficient? So move receiver away from the source. You have to move receiver away from the source, and you have to give the coupling path more. Okay, and make receiver less susceptible to emission. How will you make your emission receiver less susceptible to the emission? Modify receiver electronic shielding, etc. Add filter. So this is basically your EMC is all about these three blocks: source, coupling path, receivers. If you know either of two blocks, you can debug your EMC issue. If you know source and coupling path, you can find out what is the impacted area in the receiver. If you know, if you can solve your EMC issue. If you know source and receiver, and you can find what is the, then you can also find the coupling path in a nutshell. If you have information of any of two among these three blocks, you can easily debug your EMC issue. So make sure you should try to know about these two blocks. Okay. So what is EMC design technique, right? Minimize the source emission, minimize the path coupling, minimize the victim susceptibility, right? What is EMC mitigation technique? This is design technique. This is mitigation technique. So to mitigate the EMC issue, you need to get the separation in space. That is very important, guys. Separation in space, separation in time, and separation in frequency. There is three parameters you have to follow to mitigate the EMC issue: separation in space, separation in time, separation in frequency. Okay, right? This we have already understood. Source with controlled emission and receptor with adequate immunity, right? Let us understand making of an standard. Who makes the EMC standard? Who defines what is the limit for different test cases in the EMC? So IEC, International Committee, decide the EMC standard. Some national committee also decide the EMC standard, like BIS, ANSI, BS. Who forms the committee? User manufacturer and re-owned specialists form the committee. They first draft the EMC standard, and they collect the feedback from the user, manufacturer, and re-owned specialist, and then they release the final standard. This is like NPL, ERTL, and other government devotee in India, government calibration hierarchy in India, right? So that is how a EMC standard is being made. And what all the EMC setting institution, you should know this. This is like DoD, Department of Defense in US, IEC, International Electro Technical Commission in UK, CISPR, FCC, like ETSI, VD, VSI, VCCI, and VIS. Okay. So let us understand what all EMC standard and test which need to be done. So as per IEC 61000-4 series overview, let us IEC 61000 IC 61000-4-2, that is for ESD, 4-3 for RS, 4-4 for EFT, 4-5 for surge, 4-6 for CS, 4-8 for magnetic field immunity, 4-11 for voltage dip, and you can also see the IC 61000-3 series overview, that is 3-2 is harmonics, IC 61000-3-3 is for fecal, and you can also find some standard here, right? So guys, if you have any further question, hope you understood the EMC overview at least. If you have any further question, feel free to ask me in comment section. Thanks for watching this video, guys.